Okay, we're supposed to write this as a single logarithm. And the one that might be jumping out to you is this one. If you have log of x times y, that's log of x plus log of y, because we got two different logarithms adding to each other, right? But this rule doesn't work if you have a number out front. There's no number out front written here, so we have no rule for how to resolve this 3 right off the bat. But we can use a different property to help us. If you have log of x to the r power, that's the same thing as r times log of x, or vice versa. You could say, let's start with with the right and end with the left. So we can use this 3 and put it on top inside the argument of the function as an exponent. This is natural log. And look, I'm going to use an extra set of parentheses because it's the entire argument being raised to the third power. Like this. And then I'll do the same thing with this 2 here. Second parentheses. Okay, the 3 is an exponent on top of this entire thing. The 2 is an exponent on top of this entire thing. And so now we can expand that a little bit more. The 3 is on top as an exponent, so that's now natural log of x to the ninth, y to the third, because powers on top of powers multiply. 3 times 3 makes 9. And same thing in here. This is y to the second, and then it's z to the fourth because of multiplication, not because of addition, right? Okay, and now we're ready. Now we have a logarithm without numbers out front, so we can just use this rule. We can say that it's a log of the two arguments being multiplied. So this is natural log of x to the ninth, y to the third, times y to the second, z to the fourth. And so natural log, that's natural log x to the ninth, and then we can combine the y powers. So those add because we're not having powers on top of powers. We're doing y to the third times y to the second. The bases are the same. So there's our fully simplified logarithm.